Hey TurtleBot users, many of you have written in to us requesting more information about how Odometry works, and so today I'm going to give a quick primer on Odometry on the TurtleBot. So, what is Odometry? If we go to our favorite source of information on the internet, Wikipedia, we'll find that odometry is the use of data from moving sensors to estimate the change in position over time. Odometry is used by some robots, whether legged or wheeled, to estimate, not determine, their position relative to a starting location. You can see from this diagram that the odom frame and the base link frame both start at the same location at time 0. And as time progresses, our robot moves, and our base link moves with it. And so here you can see at the end of time, or some time in the future, we have the base link relative to our odom frame. So how does this work on the TurtleBot? Well, the TurtleBot receives wheel sensor data from the iRobot Create, and that's passed along the serial cable to our TurtleBot node. And in our TurtleBot node, we use the wheel sensor data to compute the odometry as time moves forward, and publish that on the odom frame. But one thing that we need to remember about odometry is it's just an estimate. And a real world example of this is on our car. Our car has an odometer, and it tells us how far our car goes. But remember that the odometry can be more or less accurate depending on the radius of your tire or other conditions. Maybe your wheels slip on the pavement. And as we learned from Ferris Bueller's Day Off, that the sensor can be fooled. So here in my diagram, I'm showing that we measure how far the base link has gone, but actually in the real world, the robot may have not moved that far. And so this could be a source of error for your robot while it's driving around. So one of the things that we try to do on the TurtleBot to improve this is we've added a gyro. And the gyro is integrated into the TurtleBot, the iRobot Create base, by sending the gyro analog signal into the analog input of the iRobot Create base. That's bundled up with the sensor data and sent on to the TurtleBot node, which is then passed on to Robot Pose EKF. The Robot Pose EKF node uses the gyro and the odom data to compute and publish the more accurate odom combined. So, what is Robot Pose EKF? So, Robot Pose EKF is just an extended Kalman filter. And an extended Kalman filter uses measurements observed over time containing noise and random variations and other inaccuracies to produce values that tend to be closer to the true values of measurements than their associated calculated values. So, in a sense, we're getting a better calculation of our base link over time. And this is done through kind of a weighted average. And we basically use covariance matrices to say how confident we are in the different datas that are coming from our robot. And so here in my diagram I'm showing that as time progresses, our odom combined link or frame will be more accurate relative to our base link because of the extra data that we've incorporated to our odometry, like in our case, the gyro. So one thing I'm trying to reiterate to you is that the TurtleBot node publishes odom, which is the transform from odom to baselink. And Robot Pose EKF publishes the more accurate odom combined, which is the transform from odom combined to baselink. And so when we look at our robot, you may see two links that are quite a bit differing and show us different information about the robot. And that's because one has more information than the other. So that's about all, folks, and I hope you've enjoyed this segment, and thank you very much for listening, and have a good day. Bye, guys.